And this is the agenda that we have tentatively drafted. So I will start just introducing briefly this program for those that haven't heard the previous presentations about it. I will go very fast just to give some information about the structure. Then if you have additional questions, please feel free to ask at the end or to ask by email for additional information. And then I will leave the word to Professor Salman Khetani, which is the director of a master graduate student program at the UIC, for the rest of the topics on the agenda. So, thanks to this program that now arrived at the 9th edition, it is possible for our students to enroll also in Master in Biomedical Engineering or also in Biomedical Informatics, but this actually was never performed for anybody previously, while being enrolled in our laurea specialistica at POLIMI. The advantage of this program is that formally it doesn't include the prescription to do additional credits, which instead is what happening at Politecnico for other double degrees programs, in which you have to add credits in order to complete this. Here, the number of credits to graduate at POLIMI doesn't change. The program is composed by 3 semesters performed at POLIMI and 1 at UIC to follow courses, and 1 additional semester at UIC to develop a thesis, and then practically 1 additional semester at POLIMI to complete the thesis and or to finish your exams for what are the Italian, let's say, exams at POLIMI. Then you have to do 2 master defenses, 1 at the UIC, which traditionally was in May or December, but now I understand that everything is more flexible after COVID. And it is a discussion at POLIMI, where usually the thesis that you defend at UIC is very similar from the thesis that you discuss at POLIMI, so you don't need to do 2 different theses. Besides, there could be some additional work that will be required to you for POLIMI side, let's say.
Enrico.
Yes, hi Jenna.
Hi, if I could just interrupt. Have you recorded the meeting?
Yes, I did.
Oh, excellent. Okay, thank you so much. Hello, everybody.
No problem.
Don't make my mistake.
So, fundamentally, this is the structure of the first year, where you are at POLIMI, you are enrolling yourself for the master, the laurea specialistica. In the first semester, you do all your courses, while you complete the inscription to the master UIC. In the second semester, you take your POLIMI classes, and you will choose 3 classes that have a mapping with 3 courses at UIC. There will be some preliminary advisor matching. And then in the second year, you go in the first semester at UIC, where you take classes for 20 credits, and you finalize your advisor. And then you stay an additional semester to prepare your thesis, and you do this at UIC. Actually, in this semester, you can also take one additional class, and usually you finish with your master defense. This is mandatory, and of course, when there are some details about some tuition fees that are related to this additional semester, probably Professor Khetani is going to talk a little bit about also this, also for the opportunities that you will have to get some payment while you are studying in Chicago in this additional second semester. And then you come back, and usually here you have, according to your career level, how many exams you will have behind, let's say, 1 or 2 semesters to finish your classes and to graduate at POLIMI. A note, if you are already enrolled at POLIMI as first-year master student, it's still possible to apply, but with specific constraints that we can evaluate case by case. So in case there are somebody of you already enrolled in the first year that would like to do this, please draw me a line separate later, and we can evaluate this possibility for you. While you are at UIC, at POLIMI, the 3 courses that you can take that are mapped also as UIC courses are for now 3 courses to be chosen among these exams. This list could be changed over time, so you will be updated by the time you'll have to make a choice. And the exams will be taken with the UIC modality. So this means in the first possible exam date and one shot. You don't have a possibility to retake the exam, and if you fail, this will be registered as a fail in the UIC, let's say, report. While you are UIC, there will be 3 courses that would be mapped with 3 courses at POLIMI, plus some seminar course and independent study done towards the thesis. And this activity will be mapped with a laboratory class at POLIMI. So a total of 20 credits for your time at UIC during the semester. In the additional semester, as I said, that you are at UIC for the thesis, you could take up to an additional class that will be recorded and converted with 1 exam at POLIMI for a maximum of 5 credits. This is the voting, both sides, POLIMI and UIC, with the 2 corresponding ranking systems. And then there are some additional rules which are actually valid for UIC. So the overall final mark of a UIC course must be at least C. The overall average of the grades must be at least B. And if you take a mark lower than C, this will need to be compensated with additional classes. There are some requirements. The main one is that you have an average score in exams of a laurea triennale larger than 24. And of course, some language requirements. You have to have a valid certificate among the ones that are accepted at UIC. And you can also participate if you graduated in a bachelor outside POLIMI, but we need to confirm your previous career. And all the admission is in charge by UIC. It's not POLIMI related. You still will have to consider some rules when you will have to create your study plan for the POLIMI study plan, but I can assure you that we have no problem because we are always able to accommodate exams that you do at UIC. And in case you can also use this accredito, which is what we use normally for Erasmus, to map for courses when there is not a specific mapping in a course at POLIMI. Some deadlines, so the application will start, let's say, from mid-September up to some day in November, which I don't know exactly the final deadline, but maybe Jenna will tell us. So you are perfectly on time if you desire to apply to this program, and then the other dates will follow accordingly. So if you are interested, you can send me an email, and then for infos, there is a website of UIC, a link to a PDF that mainly contains this information, except the fact that the dates are not updated, but let's say the other topics are perfectly the same. And with this, I stop sharing my screen and I give a word to Professor Khetani.
Hello, everyone. My name is Salman Khetani. I'm a professor of biomedical engineering at UIC, and I'm also the director of graduate studies. So what happens is once you're at UIC or in my care, we take care of you, make sure you're doing well in your classes. I help you match with various faculty labs. And if you're facing any issues, Jenna and I essentially are partners here to ensure that your experience goes well. So let me go ahead and share my slides. Enrico, would you mind?
Sorry, let me give you the power.
Okay.
Yes.
Yeah, let me. So these are slides that I've already shared with offline, and they can be shared with you afterwards. And basically my goal is to essentially tell you a little bit about UIC Biomedical Engineering, a bit about our some labs that have mentored students from Politecnico di Milano before, and then just basically answer any questions you might have, as well as I have some alumni of the program who are here on the line who are going to basically answer a few questions that I have for them as a way to get started. So that's sort of the agenda. And just very briefly, UIC has a very rich history of biomedical engineering. So there's 150 biomedical engineering programs in the nation, in the US, and we're one of those 150, but we are actually one of the oldest biomedical engineering programs in the nation. We started off in 1965, actually, as a collaboration between a hospital or set of hospitals and University of Illinois Chicago Circle, as it was called at that time. So it was really this start of this biomedical engineering, or bioengineering as it was called back then, began as a collaboration between the hospitals and engineering, which is really, if you think about biomedical engineering, that is one of the advantages of this field, that we are very much collaborating with medical professionals. And then as time progressed, eventually University of Illinois at Chicago was formed by merger of two institutions, University of Illinois Chicago Circle and the University of Illinois Medical Center. When these merged, it formed UIC in 1982. And right at that year, bioengineering became a department in the UIC College of Engineering. And then over time, we established several BS and MS level programs, including in bioinformatics, for instance. And then in 2011, this department of bioengineering became the very first department at UIC that is part of two colleges, College of Engineering and College of Medicine. This is a really important point. Because we're part of two colleges, we have access to resources of both colleges, we have access to expertise of both colleges, and our students, our graduate students, including from your institution, very much benefit from this very close collaboration we have between engineering and medicine. And then more recently, the department was renamed, I think a couple of years ago, was renamed as the Department of Biomedical Engineering. So now we have changed our name, but the concept is essentially the same. So some interesting facts about UIC BME. We have 30 core faculty and greater than 100 adjunct faculty. So these core faculty, what it means is that all or some of their salary comes from our department. And so they're part of our core faculty. And then the adjunct faculty typically are in different departments where the Department of Biomedical Engineering may not be providing them salary, but some other department is, but their research is tied with biomedical engineering. It's linked with biomedical engineering. So you have a choice of many faculty to pick from for your thesis, either core or adjunct. As I mentioned, we have a strong collaboration with medicine. We have more than 100 PhD students now. We have almost 100 MS students now. These data is a little bit dated. We have very strong diversity. Almost 50% of our student body is women, and obviously the other is male. And we have several research strengths. So we have research strengths in quantitative biology, biomaterials, mechanics, nanotechnology, tissue engineering, orthopedics, etc. And because UIC is an R1 institution, what that means is that the top 20% of the institutions in the US that get research funding, they're considered R1, Research 1 institutions. UIC is in that top 20%, which means that we spend almost $500 million of research funding every single year. So you're going to have a lot of choices with regards to the labs that you work in. In terms of our stature, we have been growing very steadily over the years. This is one set of rankings for biomedical engineering programs, and you can see that we compare very favorably with some very amazing universities in terms of research expenditure. And this data is from 2021. This year, we're projected to spend more than 10 million in research funding. So while we're no Stanford, we're certainly very close to a lot of these institutions. And then within these institutions, they typically rank faculty who are the most well-funded. And you can see that many of our faculty are in the top 100 of the funding expenditure in terms of their stature. So the point is that if you were to come here to do your master's, you're going to get a world-class education from world-class researchers and professors. But, at the end of the day, you're going to come to Chicago, and Chicago is a wonderful city. I'm sure the alumni that we're going to interview a little bit later on can testify to that. Chicago is amazing sports, amazing restaurants, architecture, entertainment. There's, you can never go wrong with a big city like Chicago. People are very friendly. So I've lived in all over the world, many cities all over the world, and I will say that Chicago is my favorite city and in a bunch of places that I have lived in as well. So I'm not going to belabor the Masters of BME. You've already kind of talked about the sequence of first semester, first year in Italy, and then the second year at UIC. But if you wanted to kind of see how many credits we require for the Masters, some of the various nuances, these slides will be available to you, and you'll be able to look at some of these links to see what the Masters entails. Some of the students who do Masters in our program end up staying for their PhD, and you'll actually talk to a few students like that today. And so these are some of our PhD requirements as well. Again, I'm not going to read through these slides. They're just there for your reference in case you want to see how many years it takes, how many credits it takes, what's involved in these degrees. But it's there for your benefit. Funding. So funding is always something that people ask about. So typically what ends up happening is when students from your university come here the first semester, typically they are self-funded. They're typically paying tuition, they're paying their living expenses. In the second semester, so typically spring semester, if you're able to get a research assistantship with a faculty member, typically they will pay you stipend and it will waive the tuition. So if you're able to find a faculty who has research funding, who's able to appoint you as a research assistant, you'll be able to get a stipend per month, living stipend. And on top of that, if you're at a certain threshold, your tuition will be waived as well. So this is a really nice benefit that of being a research assistant if you're able to find a lab that has funding. Now, that is the last part is important because the lab has to have federal funding in order, or federal or some sort of other funding in order to appoint you as a research assistant. So as you're looking for labs, it's important to ask this question: do you have funding for a student in that second semester? That's an important question to ask. Additionally, some of our students are also able to become teaching assistants in the spring semester. It's not so easy to get teaching assistant slots, but it is possible. And sometimes our students will become teaching assistants in other departments. So there's a bunch of different possibilities to get funding as a master's student, and these are some avenues that you can explore. There are other funding options. Many of these apply to domestic students. Some of them international students can also apply to. So there's always money somewhere, whether it's a few thousand or a few tens of thousands. And if you sort of look around, you should be able to get funding for your research. We have had students from your university doing a dual degree MS here who have won some of these awards as well, including best thesis. So, you know, typically students from Politecnico di Milano are quite successful at UIC. So if you think about doing, if you want to come here to do your dual degree MS, and if you want to come here and do a thesis, you have to kind of think about what the process is in being able to select a lab. And what I've done here in this slide is I have kind of outlined what the best procedure is to go look for labs. And so first of all, you have to kind of do your homework. You have to look at these various websites. You have to look at various labs. And I can also help you. If you're interested in this program, you can always email me and I can also help you navigate the various labs we have. But first you do your homework, you sort of figure out what labs are out there, what might interest you. And then you essentially have a conversation with the faculty member by providing them your resume, by providing them your statement of interest, by meeting with them over Zoom, by meeting with their students. So typically it's a very much of a, you don't just sort of, sign up with a lab without doing your homework. It's really important that you know the research that they're doing, the type of mentorship style that they have, the type of lab culture they have, because all of those things are important to make you happy as a graduate student in a research lab. So I've kind of listed the key things here. These are the two key websites. And again, you don't have to take these notes. These slides can be provided to you, but these are the two key websites that are important. One is the faculty we have, both the core and the adjunct faculty. And then the second is the research labs that we have. These are not all the labs we have. We have some labs outside of BME that have also mentored BME, Politecnico di Milano dual degree MS students. But nonetheless, these are the labs that are advertised on our website. So feel free to please take a look at these two websites to learn more about our programs. Now, what I'm going to do, and I'm sorry this is a lot of information, but I think it's important to kind of give you a flavor of the type of research opportunities that are at UIC and in our department. So what I'm going to do is basically in one slide, I'm going to show you a few laboratories we have. This is by no means exhaustive. There's many other labs. As I told you, we have 130 different faculty you can pick from. But I just wanted to give you some info on labs that I know have successfully mentored students from POLIMI and those students have gone on to either get industry jobs or pursue their PhDs or become consultants, etc. So one lab is that of Dr. Tom Royston. He's our department head. His focus is on acoustics and vibrations. He essentially deals with the mathematics and the physics and the applications of MRE, which is elastography, essentially, MRI-based elastography. And we have a very strong set of imaging faculty in our department, and Dr. Royston is one of them. And he has successfully mentored, in fact, you can actually see one name right here. He has successfully mentored several students from Politecnico di Milano. Another imaging lab that we have is that of Dr. Kamran Amanaki. He does photoacoustic imagings for various applications, like, for instance, detecting brain injury non-invasively, looking at oxygen saturation and other sorts of blood parameters. he uses a combination of light and ultrasound to essentially do photoacoustic imaging. So he has a very amazing lab that does that type of research in case you're interested. Dr. Xincheng Yao is probably our most well-funded investigator in our department. He does ophthalmic imaging, so he does imaging using optical coherence tomography and other modalities for the retina and for the eye. And now I think he's doing other organs as well. But he has a very well-funded lab, has mentored many students, as you can see. So, you know, and again, a world leader in OCT, optical coherence tomography. We also have a fairly new professor who's been at UIC for a while, but she just started as an assistant professor in our department. She does MRI research in both the data acquisition, the data analysis, applying it to various diseases like breast cancer. So if you wanted to do research in MRI, sort of, you know, standard traditional MRI and its innovations around it, Dr. Karman, Muge Karman, is actually quite powerful in that. So that's 4 imaging faculty I told you about: Dr. Royston, Dr. Avanaki, Dr. Yao, and Dr. Karman. We also have some other faculty in imaging as well. So if you're interested in biomedical imaging, various modalities of biomedical imaging, UIC BME is very strong in imaging. And we have had many students from Politecnico di Milano who have been very successful doing imaging-based thesis. The other area we're also strong in is wearable technology and robotics for rehabilitation. So one lab is that of Dr. Hanana Ismail Begi. She develops essentially wearable devices that have electronic interfaces with them to detect various biomarkers, to be able to control things like computer from using your tongue in case your arms are no longer functional. So she has been doing this sort of wearable technology for a while, and she, I think, is giving a seminar at your institution, or maybe it has already passed, but she I believe has given a seminar, or will be giving a seminar shortly at your institution. She's there physically right now. The other lab we have is that of Dr. James Patton. So Dr. Patton is unique in the sense that his laboratory is at the Shirley Ryan Ability Lab. This is a very famous rehabilitation institute lab in Chicago, and many faculty work at this lab, Shirley Ryan Ability Lab. They interact with patients who have had mobility issues or have had stroke or maybe need prosthetics. They work with these patients to try to figure out how to get their daily life back in terms of their movement, in terms of their ability to do daily tasks, for instance, walk or be able to put their clothes on, etc. So Dr. Patton uses virtual reality and robotics and human machine interfaces to try to figure out how to get these patients to progress towards becoming more independent. And so he's very well known in this area. And if you want to do robotics, if you want to do rehabilitation sciences, virtual reality for this sort of rehab applications, Dr. Patton is a world leader in it. We also have another faculty whose slide I don't have, Dr. Ming Wu, who does a lot of work with biomechanics and essentially using biomechanics to try to figure out how to get patients to walk again. So we have 3 faculty I mentioned: Dr. Ismail Begi, Dr. Patton, and Dr. Ming Wu in essentially rehabilitation robotics area, which, so again, very nice group of faculty in that area, if that's something you're interested in. And then we have several faculty in cell and tissue engineering. So if you want to work with living cells, if you want to work with living tissues, we have world-class faculty in that area. We have one faculty, his name is Jaewon Shin. His lab is called Sculpting Regeneration, and they use biomaterials like alginate, they use microfluidics, and they try to build small cellular units using materials and cells and microfluidics to then control cell behavior, to then control cell secretions, and then use those encapsulated units for therapy. So for instance, they can use these small cell units for lung injury, they can use it for liver injury, they can use it for bone marrow injury. And so it's a really cool lab because they're using not only materials, not only cells, but they're also using microfluidics to essentially create these very specific cell units. We also have a very famous lab here from Dr. Eben Alsberg. His lab is, Dr. Eben Alsberg is really well cited, really well funded. He has been inducted in the National Academy of Inventors, which is a huge deal in the field, especially in the US. And his lab focuses on tissue engineering, again, using materials, using cells, using 3D printing to essentially build tissues that could be used for various end-use applications, like for tracheal replacement, for instance, or cartilage replacement or bone replacement. So his lab is also very cell and tissue engineering oriented. My lab is called the Microfabricated Tissue Models, and we basically engineer living tissues for drug development and cell therapy. My lab specializes in liver. So here's an example of a microfluidic device that can create essentially liver organoids. That liver organoids could be used for drug toxicity screening. They could be used for developing new therapies against global diseases like fatty liver disease. They could be used for 3D printing, for instance, to make larger tissues for implantation. And so liver has been our traditional expertise, but over the last few years, we've also gotten into heart. Here's some beautiful cardiomyocytes that are micropatterned, surrounded by fibroblasts. If you've ever seen any cardiomyocyte physiology, these look gorgeous. We can measure their voltage changes over time. So my lab does liver tissue engineering, cardiac tissue engineering, and now we're also getting funding for intestinal tissue engineering, placental tissue engineering. So again, lots of different organs that we engineer, and we work with a lot of different cell types, including stem cells. We also have, within the cell and tissue engineering realm, we also have the lab of Dr. James Lee. Dr. James Lee studies Alzheimer's disease. So if you have a personal connection from family members, for instance, who might have Alzheimer's and you're passionate about this disease, making a difference in it, then his lab is outstanding in the sense that they tackle Alzheimer's from many different angles. They tackle it from discovering molecules that might cure Alzheimer's. They tackle it from studying cell mechanics of Alzheimer's and how Alzheimer's essentially forms in vivo and how the mechanics of the brain changes. Dr. Lee's lab uses things like atomic force microscopy. They use various biological techniques, molecular biology techniques to try to study how Alzheimer's develops. And so if you're passionate about Alzheimer's, you can't go wrong with Dr. James Lee's lab. Now, what I told you so far is several faculty in cell and tissue engineering. I told you about Dr. Shin. I told you about Dr. Alsberg, myself, Dr. Lee. Those are the four main labs who are doing cell and tissue engineering, and all of them have mentored students from POLIMI in the past. We also have several labs that are sort of in between cell and tissue engineering and more diagnostic devices or more instrumentation. So they're not classically cell and tissue engineering, they're more devices lab, but they are using cells for various applications. So one of those labs is Dr. Ian Papatsky's lab, and he has mentored a lot of POLIMI students. I have mentored 4. Dr. Papatsky has mentored 7. So you can see that a lot of those students have been very successful. Dr. Papatsky does a lot of different things, but most importantly, he does essentially the use of microfluidics and 3D printing technologies to develop assays, miniaturized assays for various applications. Those applications could be for biosensing of various analytes. They could be for oncology, to try to detect rare cancer cells in blood and try to figure out whether those cancer cells can be treated with specific drug cocktails before those drugs are given to the patient who might have that cancer. So he is well-known, well-renowned for this application, and he has been making a lot of amazing discoveries in it. But if you wanted to do microfluidics, if you wanted to do diagnostic assays, if you wanted to do cancer biology, his lab is amazing for that. The other lab that has mentored a lot of different POLIMI students is Dr. David Eddington's lab. So Dr. David Eddington develops essentially microfluidic or different types of instrumentation to control gases in cell culture, so oxygen, hydrogen sulfide, to essentially precisely control the gas environment so that the cells are behaving as they would in the body. More recently, he has been looking at essentially inducing pressure, fluidic pressure on top of cells to mimic the blood pressure in your body. So he has several devices, several high throughput devices that allow you to do that. In addition to these sort of devices that he applies to cells, mammalian cells, Dr. Eddington also focuses on doing bacterial culture. So if you're interested in microbiology, bacteriology, he also has devices that allow you to essentially create droplets of bacteria where you can study how bacteria communicate with each other, how do they attack each other, how do you get resistance, okay? You all know that taking too many antibiotics is also not good because you can be the bacteria can become resistant over time. How does that happen? How does that happen at the individual cell level? And can you make devices to study that? That's also another important part of his lab. And he has mentored several POLIMI students, including one that you'll hear from a little bit later, as well as another one that's about to graduate soon. And then last but not least, we also have Dr. John Hetling's lab. So Dr. John Hetling, he, I believe, has a POLIMI student right now who graduated with their MS and now is a PhD student in his lab. Dr. Hetling is very passionate about developing electrodes for the retina. So he has electrodes that can go onto the eye like a contact lens, and they can detect electrical activity from the retina to diagnose diseases, to diagnose various ailments. And he has actually started a company on this. He is quite passionate and well versed in this idea of retinal measurements. So again, devices for either detection or diagnostic. So I kind of gave you a flavor of 3 labs in that area: Dr. Papatsky, Dr. Eddington, and Dr. Hetling. Now, I apologize, a lot of information, but I wanted to kind of give you a sense of the major themes in the department, from imaging to cell and tissue engineering to diagnostic devices. And these are only a few of the labs. We have so many more. Obviously, I cannot go into all of them, but I think you get the point. You get the point that we have amazing research. And if you wanted to come here and learn hands-on skills, this is the right program, I believe, that you could benefit from. So I think this is it for my slides. What I'm going to do now is I'm going to stop sharing, and I'm going to hand it over to the alumni who are here. And we're only 3 minutes behind, which is amazing. So I think so. We have Elena Boselli, Giulia Venturini, and Emanuele Spengero. They're here. They have graduated from the dual degree program and now are all PhD students. And what I was hoping to do is I have some questions for them. I'm going to ask a question, and then we're going to have Elena, Giulia, and Emanuele in that order essentially give their perspective on that question. So maybe let's start with introducing themselves and when were you a dual degree MS student? So let's start with Elena.
Okay, I can start. I guess. Hello, everyone. I'm Elena Boselli. I'm currently a 4th year PhD student here at UIC in Dr. Papatsky's lab. And I started my dual degree program in 2017-18. So I guess I was part of the 2nd generation, probably, of the BME students.
Wonderful. How about you, Giulia?
Hello, I'm Giulia, and I am a 1st year PhD student in Dr. Eddington's lab. And I was here for my master's student in 2020-21.
Wonderful. Emanuele?
Hi everyone, I'm Emanuele, and I'm finishing my 1st year in Dr. Khetani's lab, and the same as Giulia, I was here in 2021.
Yeah, so we have essentially 3 alumni of the program who all decided to stay here for their PhD. So I was able to get them to do this in short notice as opposed to hunting people who might have already left here. So I appreciate them being here. So my second question that I was going to ask them is, so why did you choose to do this at the dual degree? You know, there's a lot of steps to take. There's a lot of work to do. So why did you choose this, Elena?
So I guess I was always interested in having like an international experience while I was doing my undergrad or my bachelor's at POLIMI. And of course, the major other option would have been doing an Erasmus somewhere, but I was really fascinated by a presentation that actually Dr. Sant'Ambrogio gave us. And so I said, okay, that's a big challenge, but since we're going away, let's do a big step and let's jump in.
Thank you, Elena. Julia?
Yeah, so very similar to Elena, was interested to like have an experience abroad. And when I saw the program, you know, getting a double degree and a lot of lab experience, it really, really fascinated me. So that's why I decided to did this double degree program with respect to an Erasmus or a thesis abroad.
Wonderful. Emanuele?
And just to add something, I think the thing that this program gives you more than an Erasmus is the actual degree. So you get a degree that's valid in the US. And so if you want to pursue maybe a PhD, or if you want to find a job here in the US, you have a valid degree, which is, at that point, it makes your life easier, basically.
Thank you so much. Yeah, I appreciate you guys adding sort of more information from your perspective. So the third question I have is if you can maybe, briefly describe the research you did for your master's. Briefly, obviously, we can talk a lot about our research, but what research you did for your master's and basically what skills, unique skills you learned by being here and, how long did it take? Yeah, I think just maybe commenting on that would be great. Elena?
So for my master's, I was, and it's kind of like progressing now during my PhD work. I was working on electrochemical sensors for heavy metal detection in various matrices. So it's kind of like a bench lab work. But working with sensors for heavy metals such as like lead, arsenic, and manganese, and I guess like from like the experiences learned, well, I can have a like a long list, but especially what's different from like more of a POLIMI perspective, it's really getting hands-on experience on working in an actual lab, because while I was at POLIMI, of course, I didn't have that much experience, and it got like a very steep increase as soon as I started here. So I guess that's
Thank you, Elena.
important.
Julia,
One of the unique things that you can experience here.
thank you, Elena. Sorry you broke up for a second. That's why I interrupted you. I apologize. Julia, do you have anything to add or in terms of your research?
Yeah. Okay, so I actually did two theses, one here and one when I went back to POLIMI, but they had a lot in common. So my research here focused on the development of a high throughput platform for hydrostatic pressure delivery to venous endothelial cells. And then when I got back to POLIMI, I developed another high throughput platform, but it was for drug screening purposes on patients' cancer organoids. So I learned a wide variety of skills from prototyping, so 3D printing, cell culture. I did also CFD simulations. So it was a very steep learning curve, but I really gathered a lot of skills that right now are helping a lot with my PhD research.
Wonderful. How about you, Emanuele?
Yeah, and same as Julia, I did two different theses. So, and as Dr. Khetani mentioned earlier, I joined actually a lab which is not BME here at UIC. I was in the physiology and biophysics department, and there I joined Dr. Russell's lab, and we worked on developing an in vitro disease model for a cardiac disease, which is TTR amyloidosis. And then I went back to POLIMI and I joined Dr. Candiani's lab. And he was interested in using some of the skills that I learned here at UIC and apply those skills to his research. And I basically worked on studying the effect of substrate stiffness on the transfection efficiency of non-viral vectors. So the main skills that I learned here and at POLIMI as well were cell culture. I learned everything about cell culture. I did a lot of microscopy, of course, and also about like substrate preparation, so polymerization process and how cells and coating processes of like the substrates to allow cells to actually adhere to these materials.
So you heard from two labs who are core faculty labs in BME. So Elena was in Dr. Papatsky's lab, or is in Dr. Papatsky's lab, and then Julia is in Dr. Eddington's lab. And then Emanuele, you heard, did his master's with an affiliate lab, but he was equally successful as the other two. So you have many choices now. It turns out that that affiliate lab is no longer there because the faculty retired, but we do have other affiliate labs as well. And Emanuele, I was able to select him as a PhD student because of the skills he gained in his master's. So it worked out very nicely for his continued education. So the other question I have is, what advice would you give the prospective students about how to decide whether to do this program and then how to get the right lab for them? What are things that you learned as you were going through it that you can maybe impart on the prospective student? So Elena?
Yes, sure, I can start. So in selecting the lab, I guess now it's even like easier to directly connect with the professor or the students that are working in the lab after with all like these possibilities of long distance communication like Zoom or going in doing like virtual meetings. But my best suggestions are, well, first of all, to look at the website of each faculty, especially if you already have a sort of idea of area that you would like to work on, as Dr. Khetani suggested in his presentation. Like one of the advantages of UIC, it's definitely the diversity of the research you can find. Really, I'm sure you can find your own passionate, most passionate path. But so look at first at the website, at the publications that each faculty usually lists on their website, or look at the Google Scholar profiles of the professors as well. Start reading some of their publications just to get an idea of what they're actually working on. And of course, directly connect, try to reach out not only to the professor, but also to the students that are currently working with him, to ask with him or her to talk more about like their mentorship style, their kind of culture in the lab. So I guess those are the best advices.
Thank you, Elena. Julia, how about you?
Yeah. I guess joining this program it gives you a lot of skill, a lot of lab experience. So if you're interested in like learning real skill in very high quality research labs, then you should definitely join. And for selecting the advisor, just go through the websites, look at the previous paper they published, talk with former students and the students that are currently in their lab, if there are any. We are available, so if you have any questions, just email us. And we know other people that have been in other labs, so we can just like direct you, put you in contact with them, and yeah, talk with the advisor for sure, because they're able to give you infos about the current projects they have, their mentorship style, the kind of research they want you to do. So it's really important that you connect with the advisors.
Emanuele, do you have anything to add?
Yeah, I think the two most important things are, of course, the type of research that you want to do. And so for that, you need to do like your research. You go on the website, read papers about each different lab. And the other thing is the lab culture, like the people that are in the lab. So maybe what you can do is first reach out to professors and have a talk with them and see if they have a position for you. And then maybe reach out to other like previous Italian students or their current students that are in the lab and ask how they're feeling and yeah, basically how the lab is.
Yeah, so I think both, from me as well as from the three students, you heard sort of a common theme, which is that, you have to look at online as to what research topics people do. Sometimes that information is updated, sometimes it's not updated. So you have to look at, kind of take that with a grain of salt, whether, that information, because some faculty are just not very good at updating their website. Unfortunately, they get busy. That's step one. Step two is to reach out to the faculty or reach out to me and I will make the introduction. So we have actually two students who are starting from Polytechnical in this fall, and I'm helping them sort of make connections with various faculty. So I can help, or you can reach out directly. And then at the end of the day, you want to be happy doing the work you're doing. So you have to make sure you fit with the lab culture. And different labs have different cultures. Some labs have more diversity, some have less diversity, some work more, some work less. There's a lot of different styles, and I think you want to make sure that you talk to the current students, the former students, and if any faculty does not feel that you should talk to their current students, that's probably a red flag. To me, that's a red flag, because that's basically saying like, that doesn't matter, which I do believe the lab culture matters a lot. So I think that's a common theme. And then I'm going to ask one final question from the three. How do you like Chicago?
Yeah, for that one. No, I just want to add one like super quick thing according to the previous point. Like, don't be afraid to ask, especially with students or with like past POLIMI students. There are no stupid questions. Whatever, we are gonna here to help. We are here to help. And yeah, don't be afraid to network with as many people as possible to get like different inputs from different perspectives. And for Chicago, oh, it's amazing. That was one of the main reason I decided to stay for my PhD, because during the double degree, I literally fell in love with the city, because it's perfect, because it's big. You have like all the advantages of the big city, so there is no shortage of things to do all year round. But it's not as messy as it can be in New York. It's still so livable, and don't be too afraid of winter. A good heavy coat and you'll survive.
Thank you, Elena. Yeah, I've lived in the desert and in Chicago. You get used to everything, so don't worry about that too much. Julia, do you have anything else to add about Chicago?
Well, I love it because I'm living here, so for sure I love it. It's a beautiful city. It has a lot of things you can do. For sure, you can find something you like. And there are a lot of people, so it's easy to connect and make new friends. UIC has a lot of international students, so you really get in touch with a lot of different people. And yeah, the weather is not super nice. The winters are cold, so get ready for snow, wind, and etc. But it's beautiful. You really will love it. So yeah.
Emanuele, how about the summers? How are the summers treating you?
Summer is fine, I guess. It's not as hot as in Italy, like in Milan. It's way worse, I would say. It gets hot here, like a couple of weeks each year in summer, it gets pretty hot, but not as bad, I would say. And yeah, the other thing I can say about Chicago, you sometimes hear it's not like on the safer side as a city, but you just have to know where to live and where to go. If you hear that, it depends on where you live. If you talk to people that are here, it's gonna be fine. You won't have any problems like at all.
Yeah, any big city with 3 million people, you're gonna have areas that are not areas to go into. So you try to avoid those. But I have lived here. This is my 9th year. I've not had any safety concerns, and I have a lab of 12 people, and they're all so far safe. So Chicago is unfortunately sometimes in the news about safety issues, but it's a big city. There's a lot of different areas. And I wasn't joking when I said that this is my favorite city out of all the cities I've lived in. I've lived in Karachi, Pakistan, Dubai, United Arab Emirates, Milwaukee, Wisconsin, San Diego, California, Fort Collins, Colorado, Boston, Massachusetts. This is my favorite city. So I'm giving you a global perspective on the favorite city. So I think we don't have much time now. We only have a few minutes. If there's some burning questions from the prospective students, I'm happy to answer them. I'm also happy to stay longer if people have more questions, but I want to be respectful of people's time. So are there any questions people want to ask before we adjourn? It's okay, don't be shy. We don't bite. You can also put it in the chat if you wish.
Yeah, and I don't know, but like from my perspective, like Dr. Khetani, feel free to send the prospective students my information, and feel free to contact me if you have anything that comes up to your mind in the future.
I was just going to suggest maybe that Elena and Julia and Emanuele enter their email address or WhatsApp in the chat for everyone. That way everybody has it. And sometimes you think of questions later that you wish you had thought of at the time.
Yeah, and we have, Jenna also has many students who are, I only selected the 3 that I knew would cater to my last minute request, but we have many students who are here, who have been through this program. So there's a huge network. My philosophy on lots of points of feedback is that they can be good, but sometimes they can also be confusing. Because if you talk to 30 people, they're all going to have slightly different variations of their experience. So I think what you want to do is you want to take all the various elements into account, the research on the literature, the faculty conversation, the lab culture, the current students, as well as former graduates, to try to take the whole information into account as to what might work for you, because maybe one lab that works for one person may not work for another person. And I think these are all things to take into account. But generally speaking, there's a rich history of this program at UIC and Polytechnical, and you should leverage that historical knowledge to make an informed decision about where you might end up.
Yeah, so from my perspective of this 8 years and the 9 going on, I must say that it was very satisfying to listen to students having a good time, both as a students and for this choice. And then I've seen now that more people are deciding to stay and continue for a PhD, which is also a good sign that the experience is good. So I see a question, please. Open your mic. And,
yeah, I had quite a few ones, but I will be really concise. The first one is where can we find the slide and the registration of the meeting? The other one, it's for Dr. Khetani. It's about the collaboration with hospital. Is it still available to collaborate with hospitals, or doing something like Emanuele's program with collaboration with affiliated labs like physiology department and kind of medicine department? And yeah, I think the last one, it's for the 15 CFU. There are one shot for the UIC program. Are only those 15 CFU one shot, or all the years at the Politecnico, the courses at Politecnico has to be passed one shot? I don't know, maybe I got two
Now,
questions.
of course, only the 3 exams that are mapped as UIC exams, because you are taking them in the modality which is compatible with the fact that it's like you are taking them as UIC student. So the modality has to be the same for UIC, but for all the rest of the exam that you take at POLIMI, you can reject the vote, you can redo, you can decide yourself when to do it as usual as normal student at Politecnico. Just to reply to the third question and to reply to the first question, where you will be able to find this recording, I will probably post the link on the website of the CCS of Biomedical Engineering. There is already a page relevant to studying abroad, so you will find there, but it will also give the link to Jenna if she wants to add it to also a web page at UIC, in case. I will send the full recording.
Yes, and one thing I want to add about the exams is that I think we just decided within the last year that you can decide between the first and second call dates to take your exams. So I don't know what the difference is on your side, if it helps
Actually,
not
we
cramming.
were keeping the first one as mandatory.
Oh, okay.
Yeah, because too much flexibility then generates too much chaos. So
Oh,
yeah, we did that because of COVID.
right, right.
Now
No,
things are back to normal. So we are trying to get back to, let's say, the normal life.
oh, no, I think maybe I misunderstood. Like from our last visit in October, to Milan, we had talked about choosing one or the other, not getting two.
Okay, okay. This could be accommodated for next year. So for this
Yeah,
year,
yeah, yeah.
for
So
the
you're not
extra
taking all the
students,
exams at the same time.
yeah, for the extra students, we went back to the normal modality. So one shot, the first one. We could consider, if it's okay for you, one shot choosing between the first and the second date.
Okay. Yeah, and to answer your second question, so because there's a very close collaboration with the College of Medicine and the College of Engineering via BME, pretty much most of the labs you're going to work in are going to have collaborations with some physician scientists. So for instance, my lab, Emanuele actually collaborates with the head of cardiology for his cardiac work. My lab collaborates with pathology, endocrinology, pharmacology. So depending on what lab you're in, you're going to have a collaboration with a physician scientist. When I say physician scientist, meaning somebody who's practicing as a physician and is doing science. Some labs are more fundamental. They're doing more fundamental science. So they may not have a collaboration with a medical professional, but they will still be doing work that is very translational to, so it all depends on what type of work you do. If you want to work with live patients, then it's a different kind of a lab. If you want to work with very basic technology development, then it's a different kind of a lab. If you want to work with a lab that does a little bit of both, then it's a different kind of a lab. And I think this is where, as you do more homework on the labs online and as you talk to faculty, you can ask these questions like, how closely do you collaborate with medicine? What kind of professionals do you work with? And I think will be clear as you talk to faculty. But thank you so much for your questions. Any other questions we might have? Okay, I think everybody's now wants to have dinner or something. It's late there. So thank you so much. I apologize we went over 5 minutes. Any other comments from the organizers before we adjourn?
I think just to thank you for your availability, of all of you from Chicago. And I'm here in Milan, so I mean, for interested students, you can always reach me with an email for specific questions that I can reply, or you can reach Jenna in particular for administrative questions which are more related to UIC side, let's say.
Wonderful. Thank you, everyone, Chicago as well as from Italy, for attending, and hopefully we'll get you to strongly consider this program. It's been quite gratifying, and wish you all the best. Good night or good afternoon. Take care.
Thank you so much. Good night.
Good night. Thank you.
Ciao.